Okay, so let me start the session. Before starting the session, I would like to thank NIT Puducherry management and Dr. Raju sir, for giving this opportunity to be act as a keynote lecture for the prestigious ATAL workshop. So that is conducting. So once again, I welcome all of you for this keynote session, which is on image processing in robotics. Maybe I will not narrow down to robotics. Maybe I can generalize the image processing, concept of image processing, and how you can do the image processing with a case study. So this is what in today's lecture I will be going to deliver with the time what they have given to me. Okay. So as a short brief, uh, again I'm introducing myself. Myself, Dr. Gunji Balamurli. I'm working as senior assistant professor in VIT University at Department of Design and Automation. I'm also the co-member in the Cyber-Physical Systems at School of Mechanical. Okay, so these are the contents which I will be going to deliver in the today's keynote lecture. Coming to the contents list, what is AI, artificial intelligence, and body classification of artificial intelligence. Maybe mostly we have a confusion between machine learning and deep learning. So in today's keynote lecture, we will discuss in detail what is machine learning and deep learning with a simple and very useful example. Then I will go with the introduction to image processing. Then what are the steps that will be there in the image processing? And after completion of these steps, I will study with the case. I will deal with a simple case study, and in that case study, I will be going to teach you that how you can use the Matlab for connecting the Arduino and how you can execute the program with the help of image processing and interconnect it to the Arduino, which it can execute the output, that is trigger. So these all sort of things that we can discuss in the today's session. Okay, so mostly I think everyone utilizing this name in nowadays very oftenly, that artificial intelligence. Okay, so in today's keynote lecture, that we can see what actually artificial intelligence and how the perception will be there in the artificial intelligence and how the things will be there. So this all stuff that we can discuss in the today's keynote lecture. First of all, artificial intelligence will have three things that we want to keep in mind. One is reasoning. For the after reasoning, we have to provide the solution. After providing the solution, we have to adapt that solution. So these are the three things that mainly will be there for the artificial intelligence. Okay. Then let me discuss one by one in step. So what is reasoning and what is adapting and how you can execute. So these all things we can see. First one is generalized learning or adapting. Like a machine is there. We want to teach or we want to tell something to the machine. So that is called as adapting or generalized learning. Like if you see this example, what I am showing on the PPT. So I am taking a robot, I am keeping the robot in the field. Now, due to the intelligence that we feed to the robot, it will analyze the surroundings and it will act accordingly to the surroundings. So that is called adapting. So whatever the situation that we have given, the robot has to adapt to that situation and it has to behave itself. So that is basically call it as generalized learning or adapting. Okay. Now the second thing is that after adapting the situations, if a problem came, then it has to have the ability to reasoning. Like if in the presentation you have seen, the robot is given two paths. One is a ordinary paved path and one is the rocky path. Now the robot has to think that which path I have to go so that my work will be optimal. So that is called as a reasoning ability. So choosing a best path. Okay. So like for your understanding, I can go with a simple example so that you can understood very easily. Suppose think that if it is a field, you think that this is a field, and let us think that the machine or robot at this position. Now the robot has to move to this position. Now in the general case where there is no obstacles or some other things, So what you can see is that directly you can go from this point to this point, where I can call it as a optimal path. Okay. But if the situation, if I take in that way, so I'm taking a field. Now the robot is at this position. The robot has to move to this position. Let us see that there are obstacles are there between the starting point and ending point. Now the robot has to think that which path it has to follow. So this is called as a reasoning ability. So this will comes by the techniques that we are using. So that will comes in further slides. What are the techniques that you can use for getting the reasoning ability? So this is basically call it as a reasoning ability. Now, after reasoning ability, then I chosen the path in the previous example. Let us say this is the path I chosen. Then how I can solve that problem? How I can solve that problem? If you take this one, in this case, the robot has to cross the river. But the robot, if the robot has to cross the river, in between some breakage is there, where the robot has to solve that problem by having a other type of payment, like a wooden type of payment or something else. So this is basically call it as a problem solving. Now in the previous situation which we have seen that, so if you have a space and the robot is at this position, the robot has to travel to this position, and obstacles are there between the start position and the end position. Then you have to find the optimal path for the robot to start to the end point, to reach from the starting point to the end point. Now to find out the optimal path, what is the solving procedure that you will use? So that is basically call it as problem solving. Okay, so if the robot is having or the machine is having these three types of scenarios or these type of things, so that we can tell that the robot will have the artificial intelligence. Now, just to hold a second. Okay, sorry for the bit of disturbance. Okay, so we are discussing that how the artificial intelligence will be there. We have three things that we want to look after. One is adapting, that is reasoning, generalizing and adapting, then reasoning, then problem solving. So if these three is there, then I can tell that the machine will have the artificial intelligence. Let us, we will go in depth what actually artificial intelligence, what is the classification of artificial intelligence. So when you speak about artificial intelligence, basically you will have two types of artificial intelligence. One is symbolic based artificial intelligence, and the second one is data based artificial intelligence. Symbolic based artificial intelligence basically refers to by reading the symbols. Like I can simply tell that image processing. So the category that will comes under the symbolic based is image processing. Simply, if I want to tell you, that is called it as symbolic based artificial intelligence. That means by reading the image, if we are extracting the data with the help of some techniques, so that is called as a symbolic based artificial intelligence. Then what is data based artificial intelligence? Now if I want to segregate some information from the bulk information, which that bulk information will be given to the algorithm. Now that algorithm will sort that bulk information based on the features that we have given. So that is called it as a data based artificial intelligence, which I can call it as a machine learning. So again, this is classified into two types. One is classification and second one is prediction. So we can discuss in detail. Okay. Now, so if you see the machine learnings are classified into three types. One is supervised learning, second one is unsupervised learning, and third one is reinforcement learning. Let us, we can have an individual discussion. What is supervised learning? What is unsupervised learning? And what is reinforcement learning? Now, let us go with the supervised learning. Okay. So for that, I took a beautiful example. The example is that I want to identify whether these images, that means whether the fruits in the images are apples or not. So this is what I want to identify with the supervised learning. Okay, so please listen carefully. Supervised learning. Now, in the supervised learning, which basically I can call it as a classification in the machine learning. Okay, what it will do, So for every type of thing, like if you take Apple, car, mobile phone, any product in the universe, that product will have
Pranam.
features. Okay, so if you take the apple,
if
you take the apple here, if you take apples here, apple is a product which will have the features. Which will have the features. What are the features in this apple? The first feature is red. The second feature is maybe you can call it as shape. What is the shape? Third is how it will look like. So these are called the features. So this feature classification will be done by the human. That means I will give the apple image with the features to the algorithm. Now algorithm will try to learn that. Okay, so these features are there. Then I can call it as a apple. These features are there, then I can call it as a apple. So the feature extraction will be given as an input by the human to the algorithm. Okay, then the algorithm will learn what are the features and it will tell that this is a apple. Okay, got it? I think supervised learning. Now in unsupervised learning, what is the concept? Here we will not segregate the features. That means we will not give whether it is red, or we will not give whether it is what is the shape. We will not give how it will look like. So these all features we will not give manually to the algorithm. Instead of that, what the algorithm will do, that suppose here two types of fruits I will give. One is apple I will give, and second fruit I will give as orange. Now the orange will have some features and the apple will have some features. Now what the unsupervised learning it will do, whatever the features that will look similar, it will group as one. And what the features will look like similar, it will group as another. That means instead of telling whether it is an apple or an orange, it will simply group that if the features are looking similar, that all parts will be made as one group. If the features are looking similar, then all the parts will make as one group. Then it will separate the groups. Based on separation of the groups, then the person output we have to decide that this is an apple and this is an orange. That means here we are not giving any features for a particular part to identify. Instead, that the algorithm will itself group based on the same features that will be there, which is given to the algorithm. So this is basically unsupervised learning. So previous one is supervised learning and the second one is unsupervised learning. Now comes to the third one, that is reinforcement learning. So the reinforcement learning basically works on the concept of reward. Basically, the reinforcement learning algorithm will works on the concept of reward. So here I took a beautiful example that the mouse was being trapped in a maze and it has to go out of the maze. Now to identify the path of the maze at different places, I will be keeping the cheese for the mouse. Now I will have a diagram here in detail so that you can have an understanding better. Okay, so I am taking a free space. Here let us think that I have made some maze here. Something maze here, something path like this. So this is finally the out path and this is finally the in path. Now the mouse started here. So the mouse started here and it has to get out here. Now instead of what you can call whether the mouse is going in a proper path or not, as I told you that in between some path I will keep the cheese. Now if suppose think that the mouse has taken this path, after traveling some distance, it finds that there is no cheese in this path, then it will think that this is not the right path. Then it will come back and it will choose other path. Now when it choose the other path, if it finds the cheese in that part, which is called it as a reward, then the mouse will think that this is the right path. Again it will go in that path and it will choose. That means here what I want to tell you is, based on the reward that it will get, how much reward it is getting, whether it is getting minimum reward, maximum reward, based on the reward that is getting, it will get the optimal path from starting to ending, or it will get the information, which is called as a reinforcement learning. So we have seen here, so one is supervised learning, second one is unsupervised learning, and third one is reinforcement learning. So the best example for the reinforcement learning is the mobile robot, if a step climbing robot or whatever the robot. So based on the reward that it is getting, so it can deviate its path, and it can update its path, and it can generate its optimal path to reach to the solution. So these are the three basic classifications in the machine learning. Okay. Now, again, a big doubt will come to us, sir, we have machine learning, we have seen different classification in the machine learning, then what is a deep learning? So deep learning and machine learning both are under the classification of artificial intelligence, and deep learning is the subset of machine learning. So I will take an example for you to understand what is machine learning and what is deep learning. Okay, as I told that we have two types of artificial intelligence that we have seen is unsupervised learning and supervised learning. Okay, now the supervised learning will comes under the machine learning, unsupervised learning will comes under the deep learning. So for that, here I have taken one example, that is car. So here I took a car example, and the algorithm has to identify that whether the object that I have shown to the algorithm is car or not. How it can identify? As I told that, first we have to do the feature extraction. The feature extraction will be done manually, as I already told you in the supervised learning. In the supervised learning, the feature extraction will be done by the human, and what the features will be there, what is the color of the car, and how the shape of the car, and what is the company. All these things will be act as a features, and it will be given by the human to the algorithm. Then the algorithm will learn that features, and if that features exists, then it will tell this is the car. So that is how the algorithm will identify which is supervised learning, which in turn I can call it as a machine learning. Now coming to the deep learning, as I already told you, is that deep learning is in other words we can call it as a unsupervised learning, where we will not give any feature extraction to the algorithm. Instead, the feature extraction will be done by the deep learning algorithm, and it will group according to the features that will have similarities. Now, based on that grouping, then we have to decide which is what. So this is basically called it as a deep learning, and this is basically called it as a machine learning. Here I have taken a simple example, that identifying the orange or apple. So this is the texture. Texture is basically feature which will be the input to the algorithm. So by that it will identify that if it is a rough, then it is an orange. If it is smooth, then it is an apple. So in this way, the algorithms will identify. If you go for the deep learning, rough will be grouped as 1, smooth will group as 1. Then the rough we have to see that it is an orange, smooth we will see it is an apple. In this way, machine learning and deep learning will work to get the output for any specified task. Now, what are the soft computing techniques? So again, it is also one of the branch for, I can call it as a artificial intelligence. If suppose, as previously also we have told that, and we have discussed that, if a problem is not able to solve mathematically, and even though we can solve mathematically that problem, and the complexity of the problem is increasing, then we can approach, or we can take the help of the artificial intelligence techniques, which I can call it as soft computing techniques. Basically, what it will do is, it will get the solution. The algorithms which we are applying, with that algorithms we will get the solution, and that solution will have approximation, not an exact one. So we can't get the exact solution like a mathematical equation. We will get the approximate solution, but the thing is that we can solve any number of complexity problem. like n number complexity problem is there. So for that also we can able to solve by using the soft computing technique, which is too difficulty and tedious time consumption, more difficulty with the mathematical models. And you know what is the beauty? The soft computing techniques have the background of mathematics. Without mathematics, the soft computing technique will not work. But the thing is that instead of taking only the mathematics, it will take other parameters like the approximation and all this stuff, and it will get the solution. That's why it can able to solve even complexity problems where the mathematical problems will do, but it will take the time. So that is what the soft computing techniques will do. So like path planning of a robot. So mathematically we can do path planning of the robot, but if the complexity or if the nature of the problem that we took, like if I want to tell that I want to do the path planning in the Mars by the rover, with the mathematical modeling it is too difficulty and time consumption will be more. We required much processes, all these things. Instead of that, we can use a soft computing technique or artificial intelligence technique where we can solve that problem with less time, with less processing. So that is what I can tell you. So soft computing techniques basically classified into meta heuristic, machine learning, deep learning. So I think this we have discussed already. Let us we have to think about meta heuristic. So meta heuristic basically depends on the algorithms which you are extracting based on the nature inspired, based on the surroundings what you are having. Like an example, I will tell fruit fly algorithm. So this is the algorithm which is there in the artificial intelligence technique. So fruit fly algorithm, it is the name itself tells that fruit fly. What it will do, you know? So it will identify the rotten fruits which is there in our kitchen, and it will go to the rotten fruit and it will eat that rotten fruit what is there present in the kitchen. Now, what you learned from this fruit fly algorithm, basically, you know, the fruit fly algorithm will travel in an optimal path from one point to the other point to reach to the rotten fruit. Okay, to reach to the rotten fruit. So that means here we will inspired from that fly and we will develop an algorithm. We developed an algorithm based on that behavior, which we are calling it as a fruit fly algorithm. Like we are having another type of algorithm, simply ant colony algorithm. What is ant colony algorithm? Based on the movement of ants, how it is searching for the food. So based on that concept, the researchers have developed the algorithm which is called as a ant colony algorithm. Like genetic algorithm, based on the genetic structure how we have with the humans. So based on that structure, the researchers have inspired and they developed the algorithm which is called as a genetic algorithm. Like there are n number of algorithms, n number of soft computing techniques are available till now to solve the engineering problems what we are facing day to day life. Like I want to calculate the stress and strain for a complexity part, then I can use these soft computing techniques. Like I want to calculate the path planning, or I want to find out the optimal parameters for the 3D printing. Like any type of problem that you are facing in an engineering application, you can take that problem and you can solve that problem using these soft computing techniques which you can get easily. So this is what basically soft computing techniques. Okay, now let us move to our concept, that is image processing. Okay, so if most of the people are mechanical background, so we don't have much exposure on image processing. But nowadays it is becoming mandatory to know what is image processing, how you can do the image processing, and how this image processing concept will be applied to the engineering applications, especially in the robotics or in the field of 3D printing. Anywhere you can able to apply. Okay, so let us see what is the concept of image processing and how you can do the image processing for getting the output from an image. Now, before going for the concept of machine vision or image processing using computer vision, so let us we have to analyze that how our vision system will work. So one thing here I want to tell you is that anything that we are developing for solving the engineering application, that is based on the inspiration of the environment what is happening. Like if you take the image processing what we are using, like computer vision or machine vision, what the thing that we are using in industrial applications, that is basically inspired from our vision system. So that's why we have to know initially our vision system, how it will work. Now based on that connection, we have to learn how the vision system or computer vision will work. Now if you see an example which I have given here, here is a boy is catching a ball where a elder person is throwing that ball on the other side. Now let us analyze this in a step by step manner, that how this process will occur. Now what the boy has to do, the boy has to see the ball, in which direction the ball is coming, and the boy has to estimate what is the velocity the ball is coming. And after estimating these two parameters, then the boy has to raise the hand according to the direction in which direction the ball is moving. Then after reaching the ball to the hand, then the hand has to close so that he can catch the ball safely. So these are the tasks that he has to do. Okay, now here, what is the task of vision and what is the task of output trigger? So these two things you have to see. The task of image vision here is to see the ball, to estimate the velocity of ball, and to direct the remaining parts to move accordingly so that the ball can easily or safely catch. Okay, now here the vision is doing two things. The vision is seeing the direction of the ball, and the vision has to expect that how much velocity this is coming. Not exactly, you can have an approximation. Okay, now if you go in depth, so we have this is the eye, which we know that we have the retina on the eye. Now after that we have an optical nerve which is connecting from the eye to the visual cortex. So this is called as a visual cortex. Okay, now that is present inside the brain. Okay, let us, I will have a some brief discussion on this one. So our eye will be connected to the visual cortex through optical nerve. Our eye will be connected to the visual cortex through optical nerve. Optical nerve will be connected, will act as a cable where the information will pass through the cable and it will reach to the visual cortex. Okay, I will tell in our language. So I saw the image will be feed, or otherwise I can tell like this. I have a camera, I took the image from the camera, I have the image, and I will send to that image through data cable to the computer. Then the computer will process that image and you will get the output of the image. So this is what it will do. Now in the similar way, if you take the vision of our thing, the eye will be act as a camera, and after capturing the image from the eye, it will send it to the visual cortex through optical nerve. In the visual cortex, which I can call it as a processing unit, it will do the processing and it will send the output of the processing to the brain. Then the brain will activate other organs in our body accordingly what the signals that was sent by the visual cortex, and we can safely catch the ball. So this is what will happen. Now I will have a retina where it will do the preliminary processing. What is meant by preliminary processing? Preliminary processing is that what is the color of the ball and what is the estimation direction. So these preliminary action will be done by the retina of the eye, and this information will send to the visual cortex. In the visual cortex, there is a high end evolution will be there. High end evolution means direction of the ball, color of the ball, size of the ball, velocity of the ball. All these features will be calculated. Now after calculation these features, this information will be given to the brain, and the brain will act and the brain will send signals to the other organs which has to act accordingly what the information sent by the visual cortex. So by that we can able to safely catch the ball. So this is how our image processing, our vision system will work. Now based on this one, so we developed the computer vision or machine vision to check the quality or to get the information which will be applied for the industrial applications in nowadays. Okay, so this is the basic block diagram of the vision system that we are having. First, the object image ball will falls on the retina of two eyes. Then the retina will do some preliminary processing, then sent to the brain through optical nerve. The brain will have the visual cortex where it will do the heavy lifting analysis which I told. Then the processing the knowledge and stores in the brain. then the brain will command the other organs and it will act accordingly. So this is the total entire process that will be done in the human vision system to do the activities properly in day-to-day life. If anything is missing, then we can't able to predict properly that how the things are happening in the world. Okay. Now, so there are some examples that we want to look into, that where some cases our optical illusion fails, our illusion will fail. So here is the case which we have to study, that uh, this if you take this case, if you take this case, computer vision will fails to identify these two persons. Okay, if you take these two cases, human vision will fails to identify these two. Why? Because if you look this one, if you look at these two, our vision will tell that this length is more than this length, but it is not actually, true. Both lengths are same. So this is basically called as optical illusion of the human eye, where the recognition is fails, but the computer vision will success. Why? Because computer vision will works on the geometric features that are extracted from the image. So that's why in this case it will be pass, but in this case the human vision will pass, but the computer vision will fails. Why? Because the to pass the computer vision, we required n number of data, like this is the without bird data, with this is the bird image. Now we required the data set, how a person is converting from bird to non-bed. So like these interval stages of images is required. All these images will be stored in the data. By that only the algorithm will able to identify that the both the persons are same. So what I want to tell you is that to identify these two persons are same or not, our vision system doesn't require any much processing. We can easily tell. Okay, but when you goes to the computer vision, it will take a lot of time, and in some cases it may fails also due to this variation. Why? Because we don't have that much data set that it will analyze and visualize that how the transformation is occurring and how it can be identified. So this is the case where computer vision have a chance to fail, and this is the place where our human vision will fails. How? By seeing this one, we have an optical illusion that this is a smaller diameter and this is the larger diameter, but it is not actually true. All are same diameter. It's only the optical illusion that we have projected on the image. Similarly in these cases also. Okay, now this is another good example that has been trend some years back in the Facebook, that what is the color that you are seeing from these graphs. Somebody will tell the black and blue, somebody will tell that white and blue, white and gold. So this is basically that how you are seeing and our human vision perception. Here are some of the cases where our human vision perception will fails. Okay, now what is a machine vision and computer vision? Okay, so let us put into this way, that machine vision is a very long back practiced thing, so that we are having in the industries. Like we have the camera, and the camera will have the images, and the images will be sent to respective systems, where what you can call processing will be done, and you can able to identify whether it is right or wrong. So this is basically machine vision. Okay, so what the machine vision and the computer vision will lack is that, so the machine vision will have the light, lenses, sensors, but the machine vision doesn't have any processing, like it doesn't have any processing unit, but in the computer vision processing unit will be there. Okay, now in other words I can tell you is that if only image is processed, so that I can call it as machine vision, only images. But when it comes to the computer vision, apart of the images, I can process the raw data. So I am in the next slide. So I think my question put in chat box, what is machine vision techniques? What is this actually? Hi, this is Sarita. Are you in South Korea next slide? Okay, I will get back to you, Harita. Whatever the questions that you are asking, I can clarify your questions. Let me complete this presentation. I can give the time, ample time for you to ask the questions. So please let me give some time. Thank you. So we are discussing about machine vision and computer vision. Machine vision basically we don't require any processing unit. Then I can call it as a machine vision. When it comes to the computer vision, we require a processing unit. And moreover, if we are processing only the images, the digital image, what you are capturing from the camera, so that will comes under the machine vision. When it comes to the computer vision, apart of the digital images, if you have the raw data, if you have the sensor data, if you have the thermal data, if you have any in unsorted data also, that can be processed by the computer vision, which I can call it as a, that can also be processed, which I can call it as a computer vision. Apart of digital image, if you are processing any other type of information like raw data, clustered data, then thermal images, thermal scanning or x-rays, then you will have CT scan. So like if you want to identify the hole in the CT scan, like brain tumor, so that we can be done by using computer vision. That we can do by using computer vision. So that is not the digital image. Okay. So machine vision basically refers to the digital image where a camera will be there, where compulsory it has to capture the digital image and it has to process. So that is the basic difference of computer vision and the machine vision. Now, so how the computer will read an image? Here is a simple example will be there. We have different types of images. Basically, we have the color image. Color image is basically represented with RGB only, red, blue, green. Why we are representing only these three colors? Another question will get for us. Because any color can be generated by using these three colors. These are the three primary colors that we will use to generate any sort of color. Let us, I will give the example also how you can generate other colors by using these three colors also. How you can combine these colors so that you can get the other color also. So that also I can discuss. So if you see this one, if you want to uh, extract, or sorry, if you want to read the image in the computer, so especially color image, let us see how I will see. So you have three colors here. Basically three colors will be representing RGB. Then the color combination of RGBs will be converting as the other color. So that means we have the three channels. We have the three channels with including what is the length and width. So that is length and width. So basically you will have that. So B, A, and 3. 3 is basically three channels. R, G, B are the three channels. B and A are the length and width of the matrix, what you are taking. Suppose if I am taking 20 by 30. So 20 by 30 is the size of the matrix into 3. 3 is basically represents the RGB. For R color, one matrix. For G color, one matrix. For B color, one matrix. What is R color? Red color. For red color, one matrix. For green color, one matrix. For blue color, one matrix. Okay. Let us, I will go with a simple example so that you can understand easily. This is a pictorial representation that how you can generate the color. Like if I want to generate a red color, then I will take 100% red and the remaining two colors will be 0, 0, which I can generate the red color. Let us, I think these three you can understand easily. But if you go for this one, the combination of red and green will get the yellow color in the absence of blue color. Similarly, if I want this color, so in the absence of green color, if I combine the red and the blue, I will get this color. Similarly, if I want this color, that is aqua white, so I will combine blue and green so that this color will get in the absence of red. Like that. So by the combination of these three colors, we can generate any number of colors with the percentage. Let me put in this way so that you can understand easily. Just give me 1 second of time. Okay, I will make you clarity that how the color will be done. So for that, I am taking a simple matrix. Okay, so 2 by 2 matrix I will take one. 2, 3, 4. So this is the red color matrix. Then blue color matrix I am taking 3, 4, 5, 6. So then green color matrix I am taking 5, 6, 7, 8. Now I want the color, different colors. Now the overlapping of red. So 1 should overlap with 3, should overlap with 5. Okay, so intensity of red 1, intensity of blue 3, intensity of green 5 will have a combination of other color. Similarly, this one 2, 4, 6. The intensity of red color 2, the intensity of blue color 4, the intensity of green color 6 will form as a other color. So this is how you can generate the colors by overlapping the matrices of red, blue, green, so that you can generate the other color matrix, and that all things will be stored in a three-dimensional matrix where you can get a color image. I will show you that in the Matlab for you, so that you can understand easily. Okay. I will go with this one. I took an image of flower. Okay. So I want a matrix. So here I have displayed the image, which is a rose flower of red color. No, not red color. It's having the other colors also. Here it is green color is also there. Let us see how the computer will read this one. This is the output that you are getting, but you don't think that the computer will read the image directly. No, the computer will not read the image directly. Let us. I will show you how the computer will read. So this is how the computer will read. So A is having the number of columns. So as I told that this number represent the intensity of the color. So as I told that 3 colors will be there for us. So I will show you 3 channels. So it is a very long matrix. For a simple rose flower with a memory of bytes, how much matrix it is taking, you see. So these are called intensities. 120. Then 144. 168. So 192. See, this is the first matrix that up to now for the red color. So how many are there for us? Total 192 rows are there. Okay, 192 columns are there. So similarly for the blue color matrix. This is all blue color. And you will have the red color, green color also like this matrix. Okay, so this is for green color. So now I told you that you have the 3 matrix. The overlapping of intensities of the 3 matrices, you will get the different colors. So I hope you understand this one. Okay. So how the computer will read the image and how you can get the color. Okay. Now we will go to the next slide, that is types of vision systems. We have 1D vision system, 2D vision system, and 3D vision system. Basically, in 1D vision system, we have line scanning. 2D vision system, we have area scanning, and 3D system, we have the depth scanning also will be there for the 3D vision system. Okay. Now, this is the machine vision pipeline that we are having. So first, we have to do the image acquisition. Then we have pre-processing, then feature extraction, detection and segmentation, high-level processing, then application. So this is the pipeline of machine vision, how it will be done. Okay. Now, we will discuss in detail one by one what is the steps that we will have. First one is camera calibration. What is meant by camera calibration? We have to see. So before that, let me have what are the different cameras we have. So we have basically two types of cameras. One is an analog camera and the second one is digital camera. We are not using now the analog camera. We are using only the digital camera. So these are the parts of the digital camera. I don't want to stress here. Why? Because we are running out of the time. So basically, I will tell how the image will acquired from the camera. So that information I will give you. Then I will move to the next slide. First, object will be there. Then the object. You remember that you capturing an image is nothing but you are capturing the light rays. So you have to think in that way. You are capturing the light rays. Light rays are falling on the sensor. The sensor will convert it into image. So this is what will happen. Now, once the camera is switched on, you will have two things. One is objective. Objective is lens. The lens will always capture the light. Then diaphragm. Diaphragm is an opening that what is the amount of light that has to be entered, which has to be fall on the sensor. Now the next part you are having is shutter. Shutter is a closing and opening type, which it will decide that how much time the light has to fall on the sensor. Diaphragm, how much amount of light. Shutter, how much time that light has to be fall on the sensor. Now, once the light falls on the sensor will have either CCD sensor or CMOS sensor, will converts the light rays into the electrical signals, and where you have to where it will again convert into digital form. So that we don't want to discuss at present. So basically, when the object light rays coming from the lens falls on the diaphragm and allows from the shutter, which in turn falls on the CCD sensor, where the lights will be converted into the electronic signals, where by which we can convert into image. So this is what it will happen in the digital camera. Okay. Now, so here comes our part. As for image processing, we can use different types of platforms. Like you can use Python, you can use Matlab, you can use LabVIEW, any type of platform that you can use. But here I am comfortable with the Matlab, so I am using the Matlab platform to do the image processing. Now, for doing the image processing, you required some hardware packages if you want to do the image processing in the Matlab. Now I will show you what are the hardware packages. Okay. Now this is the Matlab window. If those who want to do image processing in Matlab, so for them it is quite beneficial. So please listen carefully. So you have to install some hardware packages which are related to the image processing when you go for the Matlab. Okay. And one more thing I want to tell you is that there are certain packages which the Matlab will not allow you unless otherwise it is a licensed one. If you are using the cracked one, maybe all the softwares will not be, all the hardwares will not be installed to that Matlab version. Again, please, I am telling. So maybe some persons may get difficulty while installing the hardware packages. What is the main reason is that he is using the pirated version. So if you are using the pirated version, you can't able to install all the hardware packages that are present for the image processing. Okay. So I will tell you what are the hardware packages that you want to install for your Matlab. So which I can call it as add-ons. If you go to the home, and in the home you have the button called add-ons, and if you click that one, so you have here called get hardware support packages. So you just click this one. Okay, so in this way it will get that install from the internet or download from the like that. So you will choose this option, install from the internet. Next. So these are the different packages that are there. So in these, what are the packages that you want to install is that one is this IP cameras is the package that you want to install, that I have already installed. So it is telling that reinstall. Then you will have the other package called as USB webcams. So this package also you have to install. Then you will have another package GenCam interface, GDE Vision hardware. So these are the packages that you want to install. Once if you select the button that, then you go for next. Then it will tell that to log in. So you have to log in with email ID, passcode. I don't want to do this one, and it will install automatically. So if you have your email ID and the password for the login account of Matlab, so you can do this stuff. Okay. So in that way, you have to install all these packages for supporting the image processing or image acquisition toolbox. Okay. Now, the next one which I want to tell you is how to choose a camera. So basically, you have three factors to choose a camera. Okay. Why? For different applications, you have to choose the different cameras. So it's not like that for for any application we should not use a single camera. So we have to change the camera depending upon the application. So how you can choose a camera? So based on the sensor resolution, based on the sensor size and working distance. Let us I have some technical knowledge on this one. So what is sensor? How to calculate sensor resolution, and and how to know sensor size, and how to get the working distance. Okay. Sensor size is basically the size that will be given to you from the camera itself. So when you are taking the camera, it have a sensor size. So it is a inbuilt configuration that you will get for the sensor size. Now here I want to tell you few things. As I told you that the light coming from the lens falls on the sensor. The distance between the lens and the sensor is focal length. The distance between the lens and the scene is basically what is the image that you want to capture. So that is called as a scene. The distance between the scene and the lens is working distance. The distance between the lens and the sensor is focal length. So these two lenses are very much important to analyze that which type of camera or how to choose a camera. Okay. So as you got the working distance, so then and you got the focal length, then you can find out the sensor resolution. Once you get the sensor resolution, either you can calculate the focal length, or if you know the sensor size, you can calculate the focal length, or if you know the focal length, you can calculate the sensor size, anything vice versa. So this is how, after getting these things, then based on these three parameters, you can choose which camera you have to use. Means how much length it has to be there, and what should be the focal length, what should be the working distance. Based on that, you can choose the camera, and you can use that camera for that application. Now, so first thing is that camera calibration. As I told that in the first step is camera calibration. So why we have to do the camera calibration? Basically, to avoid two errors, we have to do the camera calibration. The first one is radial error. We have to eliminate the radial error. The second one is we have to eliminate the tangential distortion. One is radial distortion, and the second one is tangential distortion. We have to eliminate. What is radial distortion? If bulging or convex or concave shape is happening at the edges, so this is basically called it as a radial distortion for the image. Now similarly, if there is a what you can call angle, if there is an angle making between the working plane and the camera lenses and the working plane, if there isn't some angle, so that is basically called it as a tangential distortion. So you have to adjust the lens, and you have to make that tangential distortion at 0. How you know that whether the tangential distortion and radial distortion is there? Once if you calibrate the camera only, then you can able to know that whether there is any radial distortion or tangential distortion is there for the image that is captured from the camera. Okay. Now, so how you can do this one? Basically depends upon the intrinsic and extrinsic parameters. Let us see what is an intrinsic and extrinsic parameters. Okay. Now, So when you want to do the camera calibration, you have to know what is an intrinsic parameter and what is an extrinsic parameter. Extrinsic parameters are the parameters which relates that whole coordinate system should be converted. The whole coordinates should be converted into camera coordinates. And what are intrinsic parameters? The parameters related to converting the camera coordinates into pixel coordinates. Okay. Let me have put in this way. Okay. Then you can understand here. Here a tree is there. Here a tree is there. And here a camera is there for me. Okay. Now inside the camera, you know that lens will be there. Then sensor will be there. Then from the sensor, you will get the image. This is the image. Now, first this is called it as a world coordinates. World coordinates. Now this is called as camera coordinates. And this is called it as pixel coordinates. So converting the world coordinates to the camera coordinates, intrinsic parameters will helpful. From camera coordinates to the pixel coordinates, extrinsic parameters will be used for converting world coordinates into camera coordinates. Intrinsic parameters will be used to convert the camera coordinates into the pixel coordinates. Let us have a discussion in this one. Okay, so these are called as a intrinsic parameters, which we will have the rotation and translation matrix, converting the world coordinate into camera coordinates. So you have a rotation matrix, you have a translation matrix. Now this is an intrinsic parameter where it will have the focal length, optical center, and skew distance. So skew distance is basically the angle that is made by the pixel, that is non-zero. So that we should not able to consider. Basically, we will consider as optical center and fx and fy. That is focal length in x direction, focal length in y direction. Then optical center cx comma cy. So with these, we can decide the intrinsic parameter. With rotation and translation, we can decide the extrinsic parameters. By using these two matrices, we can convert into the what you can call pixel matrix, where the calibration will be happened. So this is how you can convert or you can calibrate the world coordinate system into pixel coordinate system by using intrinsic and extrinsic parameters. So extrinsic parameters are related to the parameters related to the world coordinate system converting to camera coordinate systems, and intrinsic parameters related to the optical center and the focal distance in x and y direction. So based on this information, you can able to convert the, or you can able to calibrate the camera to find out whether is there any radial distortion or tangential distortion. Now, in practically, if you want to speak, we don't want to calculate all this stuff. So instead that, you have a tool called camera calibration in the Matlab. So I will show you that how to calibrate the camera in the Matlab. Okay. Now, if you go for apps, then if you go for here, in these apps, you have the image processing toolbar, image processing and computer vision. Here you will have the option called camera calibration. You can click on the camera calibration. Now it will display another unit called camera calibration unit. Now we have to import the images. So what images are this one is that the images that you have taken from the camera which you want to calculate or calibrate. Okay, so I have already predefined images. Okay, I'm loading that images, so don't worry. Keynote speaker and Puducherry. Sorry, add image. I forgot. Sorry. Images, keynote speaker. So here I took some 12 images. So you can add more images also. This is the images which I took from the camera which I want to calibrate. So the similar process you have to do for the camera which you want to calibrate and you want to use for the processing. Okay. So I am copying all these images and I am importing to the window. So then it will have a, what is the size of checkboard? And you can ask another question that, sir, why we have to use the checkboard only for calibration? because it is the most preferable standard image that we will consider for calibration of the camera. So that's why we have to go with the checkboard itself only. So please all of you take the checkboard only when you want to do the calibration with the camera. So the size of the checkboard is 25 mm. I'm fine with that one. Okay. Okay. Now, if you see after importing the checkboards, out of 12 images, 10 images are good and 2 images are rejected. Why? Because I have not taken properly that 2 images. So it has rejected the 2 images. We have 10 images out of 12. It's fine only. I don't want to do anything. Okay. So this is calibrated. Let us see what is the detected point and what is the checkboard origin. Okay. Let us I have a zoom in this one so that you can understand easily. Oh. Okay. So this is the detector origin and this is the checkboard origin. So if you see both are looking similar, so that means it is identified properly. Then you go for here, as I told, that radial distortion. Then if you want you can put the tangential distortion also and you go for calibrate. Yes. So it is calibrated. Let us see after calibrating how it can be done. One, the first two green circle is detected points. Then the square one is checkboard origin, and the plus one is reprojected points. Let us see. If you see this one, this is the actual origin, and this is the reprojected point. So this is called error. This is called as a error. So if you want exactly the information from the image, you have to minimize this error by reducing the tangential on the what you can call radial distortion. How? You can change the camera lens parameters, and by that you can able to reduce this effect by calibrating once again. Okay, so this is how you can able to calibrate. If you find this is okay, then you can go with that parameters which you set in the camera. Otherwise you have to change the parameters and you have to again you have to calibrate and you have to check whether the reprojection is working fine or not. So if you see this one, so this is the mean error in the pixel. So how the mean error will be there and how the reprojection error will be there. You have to reduce the reprojection error. So this is how you can able to calculate or calibrate the any camera using the camera calibration window that is present in the Matlab. I hope you understand this one. So we can move to the next. Okay, so I think this everything I taught you. So if you want, you can go with two coefficient and three coefficient is not required for you. So two coefficient is fine, and tangential distortion if you want, you can put. Then you can go with the reprojection error which I have shown. You have to reduce the reprojection error. Okay. Then this is examining of intrinsic and extrinsic parameters. Then we have to go for the second stage, that is image acquisition. So image acquisition, basically you use IP camera hardware or USB cam. Okay, let me put in this way. Here I will use uh, webcam as a camera, and how I can get the image from the webcam I will show you now. Okay. Okay, so let us see. This is a small code which I written. Okay, now here if you see this one, uh, if I type webcam and if I press enter, then if you are installing the webcam hardware, then it will show that what is the webcam that you are having and what is the resolution of that camera and what is the white balance. Everything it will show. Everything it will show. Now, as you know that you have the web camera and you have done all these things. Okay. So then what you have to do? I have to capture the image from my webcam. That is the second step, which is called as a image acquisition. Okay. So for capturing the image acquisition, I'm using my laptop webcam and I'm capturing the image so that I will process that image. Okay. So for that, the command which I will use is webcam, and this is the camera name which it is there, which I already told you that. So HP Vision HD camera, that is what I have written here. Then preview image acquisition, image show, then clear the command what I have written. Then I will simply press run. Add path. So this is the image. So which I was taken from my webcam. So I hope you understand that how to take the image. Okay. Okay. So then after taking the image, then if you want to record the image also, how to record the image? That is also I will show you how to record the image. Sorry, how to record the video. Why? Because in sometimes you require the image, you require the video to process or to capture the image. Like I want to check the quality of the bottles where the bottle is having it is going in a belt or it is rotating in a circular manner. There I have to capture continuously the video, and from that video I have to take the snapshot, and by that I will process the image. Now in this tutorial I will show you how to capture the video from my webcam with the Matlab command so that you can store wherever you want. So let us, I will show that one also for you. Video capture, and this is the video capture where I want to store this one. Okay, let us see. So this is basically using these commands will be used basically to capture the video continuously for a certain period of time, and after capturing that video to take the snapshot and to process the snapshot by using image processing techniques. So this thing will be used. Now the video is recording. Just give some couple of minutes so that you can get. So I'm using my HD True Vision HD camera. That is my webcam. I think it's completed. Let us see that where it is there. So I'm going with Matlab keynote speaker, and so here something. So this is what the video which I recorded from my HD cam. Okay. So basically, I think you have understand that how to take the how to record the image video also. Okay, we can go to the next. Okay, then we have seen that how to take the images and how to capture the images. Then I want to explain another beautiful app for you. That is IP webcam. So how it will work also I will show you, and you can use our mobile camera as external camera to capture the image. Especially this concept will be used in the drones to have a aerial survey and to capture the images for image processing. So if anybody interested in drone applications, I think it's a very good thing. You can please listen this one how to do. So if you go to your Play Store, if you go to your Play Store, in the Play Store, if you type IP webcam, so you will get an IP webcam for you. Okay. So if you type IP webcam, so you have the app called this one. So and you have to install that app. That's all. Once if you install that app, you just open that app. Okay. Just I'm opening that app. Okay. Now how it will work? Let us. I will show you. So just okay. Okay. So I think this thing is visible to me. Visible to you. Sorry. So I'm refreshing my screen. So this is the basically window will get for you. So when you will get the window that when you open the app IP web camera under options, so what options you have, you know. So 1 second, I will tell you. So you have the options called start server. At the last, you will have the option called start server. Okay. So in this, if you press the start server, then the start server will open. Okay. So when the start server is open, that it will show IP address for you. That IP address has to type here in the URL of the computer. Then you just refresh. So you will get the window like this. Now after getting the window, so you go for video render and you have the click here browser. When you click the browser, I think you are seeing my screen. So I think complete video is up, sir. So this video is capturing from my mobile. So that is SLA printer which I'm having in my cabin, and this is my desktop. Okay, Ganesha. Then this is something which it looks my chamber, and this is my bag, and everything I can show. See, I can show my laptop within the laptop. Okay, so this is how you can get all the things. So this concept will be used for you in the drones to capture the images for the aerial survey. So once if you do this one, then if you right click here and if you go with not this one also, then you can change the front camera also. So this is me, you can see. So then you can change the back camera. Okay, so this is the back camera which I'm showing my thing. Then you right click here. Okay, so then here you will have the this IP address you have to give in the Matlab, so that the Matlab will take this IP address to capture the image. But unfortunately for my system it will not work because of the security reason, as it is a university given system. So due to security reasons they have not allowed this option. So sorry for that one, I couldn't able to show you, but this is the code which I will provide to the respective authorities. So you can use this code to get the image captured from the mobile if you can install in drones also, and you can do the image processing. This is a very good thing. You can try it if you are getting a free time. Then step 3, that is image filtering. Here we have to look after what is image filtering. Before that, I have to tell you what are the different noises that will be there for you. Basically, we have 3 types of noises: photoelectronic, impulse, and structured noise. So photoelectronic, basically it will come under the Gaussian noise. Impulse noise, basically salt and pepper noise. Structured noise, basically sine wave. So let us we can have a detailed discussion about this one. So salt and pepper noise, basically this noise will come if any sudden disturbance is there in the signal while capturing the image. When you are capturing the image, if sudden disturbance is there in the image, or suddenly somebody stuck stuck to you, or something has happened and you fall down and you are taking the image. So that time, so the disturbance that comes in the image, I can call it as a salt and pepper noise. I will show you in the Matlab how it will look the salt and pepper noise for you. So this is the salt and pepper noise, how it will look like. So this is the original image and this is the salt and pepper noise image. Okay, but actually when you take the image, it will not look like that. As to show you the importance of the pepper noise, I added the intensity mode. That's why it is showing like this. But in practice, when you are taking the image, it will be not like that. It may be very less. So don't worry. But for your understanding only, I have added some intensity for this one and I have shown that one. Okay. So that is salt and pepper noise. Then we have the Gaussian noise. So basically this noise will be occurred when there is a fluctuation in signals. So signals means, as I told that light waves will passing through the opening which is lens and falls on the diaphragm then it goes to the shutter, then finally falls on the sensor. Now, is there any disturbance in the signal transferring from one position to other position? Then the Gaussian noise will occur. So Gaussian noise basically defined with this equation. I don't want to stress much more on that one. Then you will get the code for this one Gaussian notion. And one beauty, you know that for every noise you have a inbuilt function in the Matlab. So it is not required to write a code for that one. But instead of writing a code, you can have an inbuilt function which you can utilize that one and you can generate the noise for that one. So that is what I have done here. So Gaussian noise. So this is basically the Gaussian noise. So you can have an observed clear difference. So this is the original image and this is the Gaussian. Much difference is not there. Why? Because I have applied less intensity noise for this one. So you don't get any difference. So this is the original image and this is the noise image. So I think now you can have a better visualization. See. So no, this is the number. Okay, so this is the original image. So I hope you understand Gaussian noise also. So Gaussian noise. Then you have a structured noise. Okay. So structured noise is basically any disturbance in the electronic components. There, that time I can get the structured noise. You have different electronic components like circuit boards will be there, sensors will be there, then lenses will be there, then like different components will be there in the camera. If any disturbance came inside the components, electronic components, then structured noise will get. Okay. Now I will show you in the Matlab. For this also you have an inbuilt function called structure. So if you run this one, then you will get a structure noise. So this is how the structure noise will look like. So this is structure noise. Okay. Then after applying the noise or after getting the noise, so you have to apply the filter. Filter is basically a mask that will be applied on the image, which you can convert into some better image. So I will not tell that a complete noise will be eliminated, but somehow you can reduce the intensity of the noise. The most and commonly used filter is averaging filter. So how it will work is that, you have the number of pixels. I know that when you read the image, image will have the pixels, the intensity of the pixels. Now, if you average all the intensity of the pixels, okay, that I will come back to basic concept. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, how the average filter will work? Suppose if I want to, if I apply the average filter, now this one intensity will change. How 1 plus 2 plus 3, 3. Then here it is having some 3, 4, 5, like, and here it is having some 3, 4, 5, 6. Then here it is having some 4, 5, 3. So the element surrounding to this one, 3 elements, 3 elements, 3 elements, 3 elements. So you have to average all these elements and divided by 3, 3, 3, 3. So you will get 12. So divided by 12, you will get the one intensity. So it will be changed here. So that is what call it as an averaging. That means, so the element which is present, the neighbor elements will be taken average, and you have to replace the intensity with that. So which is averaging filter. Okay, again I'm telling. So you have a pixel and you have to take the average of around the pixels, and you have to replace that intensity with the existing pixel, which is called as a average filtering or smoothing. So this is the commonly filter that you will use to enhance the quality of the image. If you find that the image is not captured properly, then you can apply this averaging filter so that the image quality will increase. So this also I will show you in the Matlab for you, averaging filter. Right. So this is the noisy filter, and this is the average filter, and this is the original image. Now if you see, this is the original image, this is the noise image. After applying the filter, see, some noise has been reduced down. So this is called it as a averaging filter. Now you can reduce the noise in that way by increasing number of steps. So you can increase the accuracy of the image. Now, step 4 is image conversion. First, what we have to do is that in the image conversion, as I already told you that uh, we have the RGB color, and the RGB color has to be converted into grayscale color. By RGB will have three channels where the storaging is very important criteria, which is difficulty to store if you want to process much information. So to avoid that one, what I am doing is that first I have to convert into grayscale. Grayscale will have one dimension only. Okay, grays color will be there, which is ranging from 0 to 255. So that's why first I have to convert into grays color. Then after converting into gray color only, you have to do the process. Okay, so conversion will be like this. So only one dimension will be there instead of three dimensions. So that is from 0 to 2. Okay, if I have, I can show that. That code also. File conversion. Sorry guys, video recording. Okay. Okay. So this is the file conversion. So I will tell you one by one. So this figure 4 represents the grays color. Okay. So that is gray image. So if you see the gray image, so this is gray image. So you will have only one dimension of the gray image. So you don't find any three matrices, only one matrix you will find. It's gray image, which I can call this one. Okay. So then you will have, I think I have told the gray image. Then you will have, this is also gray image only. So then this is the another image which I want to tell you, that is indexed image. What is meant by indexed image? That I have to have some discussion on this one. I will go with the indexed image so that you can understand easy. Color image I have to black and white indexed image. I want to tell this one indexed image. Instead of storing the three-dimensional matrices in the computer, so what it will do is that it will form a indices. Indices are the numbers which in turn will have the combination of red, blue, green. Like here in the example I have shown, 5 is an index number which will represent this color. Now 5 is not exactly the color. The 5 is the number, but behind that one, it is the combination of red, blue, green. So red intensity is this one, blue intensity is this one, green intensity is this one. That means this is basically color map, and this is called indices. This number represents the index, and the number will in turn or indirectly represents the color map. So this is basically will use to save the memory which you want to have the color image, especially in a particular page. So for that, you can go with the indexed image. So this is the how the indexed image will be. Okay, so it is having indices and column. Then I think that's all. So then data extraction. So this is what I want to tell you. Data extraction, you can use histogram. How histogram will be useful, I will tell you. Histogram will have a plot from the x and y, like I will be the intensities and h will be the number of times, means how many times it will be repeated. So if you see this graph, that uh, intensity 2, 10 pixels are there. So intensity 2, intensity value 2, 10 pixels are there. So intensity 6, 5 pixels are there. Intensity 7, some 7 pixels are there. Like this, how many pixels are having same intensity will be given by the histogram. Why it is required? To compare the images whether both are similar or not. Okay, so this is how you can compare the images by using histogram method. Okay, so this is one image, this is the second image. Now I want to compare these two images whether both are same or not. Now if you plot the histogram for the both, by the histogram you can able to tell that how many times the number of pixels are repeating, by which you can able to tell that if the images both are matching or not. So this can be useful to match the images by the concept of histogram. By the concept of histogram. Okay. Now in this future slides, I will tell you the application of the histogram also. Okay. So I think this you have a basic code you will have. I will show that the code is also. So this is how you can. So this course, all the things I will provide to you. Don't worry. If anybody wants to do the image processing concept, so this is how you can compare the images. By these histograms, you can able to compare that both are not same. Okay. So then the next one is edge detection. So edge detection basically depends on the brightness changing. If the brightness is changing enormously, then we can tell that there is an edge. Okay. So there are the different types of edges that we are having: step edge, ramp edge, ridge edge, roof edge. I think step edge means the edge will be off in the step form. Ramp edge means gradually increasing the step. Then ridge means sudden increases in the uh, color intensity. I can call it as. Or roof means, so this is also abnormal improvement and it will stay at some point. So this is called roof. Okay, this is called ridge. This is called roof. I think you can understand. Sometime here it is staying, but it is not. Keep coming and it is going. If the edge is forming like this, you can tell that that is the roof edge. If the edges is forming like this, then you can tell that is the ridge edge. Okay, so this is basically call it as a edge detection. There are different types of operators that we can use for detecting the edges. Basically, that are Pritvite, Sobel, Ribonese, Frisch, and Laplace. Here I have used two edge detection methods, that is Pritvite method and the Sobel method. I will show you that why, because as I told that there are the inbuilt functions are there for this one. So I used that inbuilt functions and I have got this code. So this is how Pritvite, Sobel. Now this is the original image and these are the edge detection images which have detected the edge. So intensity changes. So from here to here, intensity is changing or not. So that is what the concept that it will be. Simple concept I want to tell you. Here a filter will be there. The filter will identify that where the intensity is changing. So that area will be highlighted, and by that it will be displayed that highlighted area where it can be converted into edge. So which is basically called it as a edge detection. Here I have shown Sobel and Pitway. So like that, so many edge detection methods are there. You can use these edge detection methods for processing the image. Okay. So as I told that you will have mask. So this mask will be applied so that you can get. Okay. Then here I want to show you something like how you can go with the case study with the Arduino. Just give me 1 second. I will show you. Okay, guys. So sorry, I took little bit of time. Uh, just 5 minutes. I will not take much time. Sorry for taking a little bit more time. Okay, just 5 minutes. Just I want to show you. That's all. This is one case study which I have done. So I think my browser is visible to you. Okay. Now I think you are seeing this one. So this is the Arduino which I am using. Okay. And the Arduino is connected to the laptop which I'm having here. Now here I used the Matlab. So in the Matlab, if you see the connection of Arduino, so this is the connection of Arduino, which here it is there. Okay. So if you type here the Arduino, so you will get these specifications. So here now here what I want to tell you is that you can integrate the Arduino to the Matlab, and to process this one you can have the image processing concept. Like I want to glow the LEDs in the Arduino by using Arduino, using the Matlab image processing concept. Now, for that one, initially you have to install the hardware packages that is related to the Arduino, which I have shown here. Okay, which I have shown here. The same way you have to install the Arduino packages, and after installing the Arduino packages for the Arduino, as I told that you should install the latest version, and moreover it should not be pirated one, it should be the licensed one. And if you type Arduino, it will show that what is the port and how it will be used. Okay, now here what I am doing, that just 1 second, I don't want to take much time. uh, so here, so here I am typing the script so that it will be easy for you. A is equal to, okay, then I'm using for loop.
Sir, any problem, sir? Bala, sir?
Yes, sir. One second, sir. One second.
Yes, sir. Yes, sir.
Just I am not taking much more time. Only one few minutes I will take. Sorry for the late. Just
Okay, sir. Okay.
intention is that to show how the code will do. So that is what my intention.
Okay, sir. Okay.
Okay, okay, sorry guys, actually I took the time. Okay, here I'm running the code for you. Here, you can watch the Arduino. I cleared out. So now see how the Arduino will blink, what the code I have given. See, so how I'm controlling the LED. I'm controlling the LED with the Matlab. I think you have seen the blinking. Am I right? So this can be done using the Matlab. Okay, with the what you can call incorporating the Arduino with the Matlab with a small code, you can do all this stuff. And this can be done with the image processing by comparing the two images with the histogram. Okay, sorry that I took a little bit time. Thank you very much. Thank you, Mangal. So that is what I can tell you.